IP3 DAG pathway. So first we are going with the theory part, and then we are at the same time we are moving with the diagrammatic part. Okay, so the mechanism, what is the mechanism? The agonistic drug will bind to the GPCR, that is having the GQ protein. Example is a histamine, bind to the H1 receptor, that is a H1R. So actual mechanism, first the drug binding to the GPCR. Okay, so the drug bind to the G protein coupled receptors. Okay, after binding to the G protein coupled receptor, there is a activation of the G protein, that is the GQ. Okay, what will happen after binding of this drug to the particular G protein coupled receptor? There will be the activation of the GQ protein. Okay, then next it will lead to the conformational changes in the GPR, just like same reaction. After binding of the drug, there will be the conformational changes in the G protein coupled receptor. Then alpha subunit of the GQ get activated and bind to the GTP with the dissociation of the GDP and the beta gamma dimers. Okay, what will happen after activation of the after the activation of this GQ? Okay, after activation of this GQ protein, the GQ alpha. Okay, so the GQ alpha will bind to the GDP and GTP, and the GDP will dislocate. Along with that, the GQ beta gamma dimer also will get removed. This then next what will happen after that? This complex of the GQ alpha GTP goes and bind to the membrane bound phospholipase C beta. Okay, phospholipase C beta. What will happen? This GQ alpha goes and activate the phospholipase C. Okay, that is a phospholipase C beta, and due to that activation, there will be the conversion of the PIP2, that is a phosphatidyl inositol 4,5 biphosphate, get hydrolyzed and converted into the IP3 and drag. That means after the activation of the phospholipase C beta, it will hydrolyze the PIP2 that is present in the cell membrane and convert it into the DAG and the IP3. This IP3, it is a hydrophilic in nature, and this DAG, it is in a hydrophobic in nature. Okay, the IP3, it is in a hydrophilic nature, so that it will come into the cell, and the DAG, it is a hydrophobic in nature, so that it will remain into the cell membrane.